Hey everybody, here's another power supply that makes a really good candidate for a really cheap piece of junk. This is a Codegen, I think that's how you pronounce it, that is rated for 300 watts. This is the spec label. It's rated to put out 20 amps on the 3.3 volt rail, 25 amps on the 5 volt rail, 10 amps on the 12 volt rail, 2 amps on the 5 volt standby rail, and it has a minus 5 volt rail of 0.5 amps, a minus 12 volt rail of 0.8 amps. And if you notice here, see it has the minus 5 volt rail. This is an older design. The sticker states ATX 2.03, but that may be true, but if you look here, see how it has a minus 5 volt rail. This has been exempted from the ATX specification for quite some time now. This power supply was manufactured during the time of the transition, I could say. To find a power supply that has a minus 5 volt rail was still highly common back then. Anyways, you'll notice that even the 12 volt rail at being 10 amps, in other words 120 watts, this power supply is, an older design, but they say it's P4 ready by having this plug, but not taking into consideration how much power the 12 volt rail can put out. I mean, it's rated for 300 watts, but it couldn't put out 200 watts on a good day. YouTube user Max Arcade has done a similar comparison. He used the Bestech ATX 25012Z, the power supply that comes from a lot of compact and HP computers, a 250 watt power supply, and he compared it with what I believe was a 400 or 450 watt Codegen power supply. And that particular power supply had some use on it. And not only was the internals of it really basic and missing a lot of components, but the output capacitors, almost every one of them was bulging. So, let's open this one up and have a look inside. Okay, now we're inside this unit. And this particular unit has not had much use at all on it. The fan's not even dusty. It's practically new. If you look inside here, notice these heat sinks. Not that much to them. They're pretty basic. The transformers, they're not that big. Which I've actually seen 300 watt units with smaller transformers, believe it or not. Here's where AC power comes in, which is actually, no, it's down here. They use the same color wires for the voltage doubler rather than using a separate color of wires. But if you notice down here, this is where AC power comes in. On really high quality power supplies, they'll typically install Y capacitors or an X capacitor on your AC terminals, and the Y capacitors would go to ground. Notice there's nothing here. Here's the fuse. And you notice here, a normal power supply would have spots for X capacitors, Y capacitors, and usually 1 to 2 coils. This power supply don't even have spots for the coils or the X capacitors. It actually has spots for Y capacitors, and there are actually 2 Y capacitors installed right there. I mean, it's already bad enough when most cheap power supplies have the spots for them, but this one here don't even have the spots for them. It's designed to be a really cheap unit. The design of the PCB was actually designed for a really cheap junk power supply. You'll notice up here, we have 4 discrete diodes. While this will usually get you by on lower end power supplies, which, I mean, even 250 watt power supplies and 200 watt power supplies for that matter, will still have what's called a rectifying bridge located here. A quality unit would have that rather than 4 discrete diodes. This kind of setup here cannot handle as many amps. And enter capacitors. Even most cheap power supplies from different manufacturers will still give you about 470 microfarads per capacitor. This one here only has 330. It's pretty typical to find 330 microfarad caps in micro ATX power supplies due to the small size. But these, I mean, these are wide, but they're not that tall. And the output caps are from a company called Junfu. These are from HEC. And notice here, this coil. I've seen 200 watt power supplies with bigger coils than that. Okay, let's have a look at the connections. Some of these were tied up because they were in the computer before, but I guess the computer never got used much. We have our main 20-pin ATX connector. Then we have, let's see, 1, 2, 3, 4 4-pin Molex connections. And these wires are extremely thin. Very, very thin. I mean, this is ridiculous. These wires, I mean, the main connector wires, I mean, they're pretty much the same thing. They're, with the exception of our 3.3 volt wires, they seem a little bit thicker. But notice, these wires here are very, very thin. Lots of line loss and resistance going from the unit to the connector. Not to mention the connectors seem really cheap and flimsy. They would break very easy. I mean, this unit is junk. And we do have, let's see, I believe it's one floppy connection. I mean, this unit is junk. Normally on power supplies like this, I would actually salvage, I would actually pull out the capacitors and stuff to replace, they'll use as replacements, or, you know, or in some cases with coils, I would take those out and use those to add in to cheap power supplies that have bypass. But this power supply here is pretty much so bad, I'm just going to scrap the whole thing except for more or less the fan. The fan is probably the only good thing in that thing. And the switch. I mean, you can use a switch. But seriously, this is terrible. It's a joke. Now let's have a look at another cheap power supply. Okay, on the right here is a power supply board from what used to be a Case Gears Black Steel 580 watt unit. And here is the 300 watt Codegen power supply. I mean, even this unit here, it might be able to put out 300 watts, but you'd have a difficult time doing it. At least this one here has somewhat bigger transformers and slightly better heat sinks. The coil on the secondary, the output side, is a little bit bigger, but I hear problems with these capacitors in a lot of cases. This power supply here had it easy. Matter of fact, I could probably wire it up and it'd probably still work. I only ran like a Pentium 4 system with this unit, so the capacitors haven't had that much of a life on them. They haven't had that much of a load on them. Well, at least if you look here on this unit, at least this unit has spots to where an input filter and an X capacitor would go, along with another filter. The Y capacitors are installed. An X capacitor would go right here. This power supply also uses 4 discrete diodes rather than a bridge. But if you might be able to notice, if you can see down here, they have 2 small diodes and 2 larger diodes. This unit here has 470 microfarad capacitors. But I mean, if you look at both of these units, You can tell that even this cheap unit has more stuff in the Codegen. I mean, they're both junk, but I mean, the one on the left is really bad. Okay, here we're looking at a 300 watt Delta unit. This is a pretty good comparison if you think about it. I mean, cheap 300 watt power supply back here, and a quality 300 watt power supply here. I don't have the cover to this unit, so I couldn't tell you the actual outputs and a lot of rails, but I think the 12 volt rail is probably around 15 amps or so. And by looking at the main ATX connector, this unit does not have a -5 volt rail due to a missing white wire here on the main connector. Okay, we're looking at the Delta again, and if you noticed, look at all these coils here on the input. The fuse is located right here. Our AC goes in right back here. We have these coils, an X capacitor here, another coil, and we have 2 Y capacitors, rectifying bridge rather than diodes. And here we have our 2 primary capacitors, which are rated at 560 microfarads. And if you might be able to see in the video, next to those big capacitors are 2 MOVs. This is more or less surge protection here. Having now a cheap power supply, forget about it. You notice here we got these bigger heat sinks, much bigger heat sinks, and bigger transformers. I mean, the overall design of this unit is so much better. And if you look here, you'll see these nice big old coils on the output side, the secondary. And this wire here goes to a thermistor that's attached to this heatsink. Cheap power supplies, well, the majority of them anyhow, just run their fans off of the 12 volt rail. They just run the fans wide open. But with quality units, they actually monitor the fan, they actually monitor the temperature rather, and control the fan based on how hot the unit is inside. So if the unit is nice and cool, it'll cut down the fan a bit because it don't need so much air going through it. So anyways, that's just another comparison video between cheap power supplies and quality power supplies. I mean, a really junky 300 watt power supply versus a quality 300 watt power supply. Any questions or comments? Let me know.